GCSE Physics boosters, uses of electromagnetic waves. Now, I'm not going to do all of these in this video because you don't need to know a great deal about them, and there's a few of them I've talked quite a lot about already in other videos, but this is what the specification says. So radio waves, television and radio, we need to know a bit more about them. Microwaves for satellite communication and for cooking food. Infrared for electrical heaters, for cooking food and for infrared cameras. Visible light, fiber optic communications. Ultraviolet, energy efficient lamps and sun tanning. And X-rays and gamma, medical imaging and treatments. And if you've watched all my previous videos, the ones about radioactivity, you'll know a bit about that already. Now, radio waves are produced by oscillations in electrical circuits. Now, I've put this frightening electrical circuit up there, and you need kind of A-level electronics to understand what the hell's going on there. But basically, it's producing an oscillation. It's producing an alternating signal, an AC signal. And then it has an antenna, which is that bit sticking up on the left-hand diagram, and that produces the radio waves. Just a little bit of interesting thing you don't need to know. AM and FM, amplitude modulation. You've got a high frequency oscillation, and then the audio signal, which is a lot lower than that, is kind of on top of it. The amplitude changes, and that is what the high frequency signal carries. And any idea that's amplitude modulation? How do you think frequency modulation works? Well, instead of changing the amplitude, you change the... You don't need to know. Get on with it. Okay, now at the other end, your receiver has an aerial, and the electromagnetic wave comes along, and basically the electrons in the aerial, the oscillating electric field makes them move up and down the aerial, and that produces an AC signal with the same frequency as the radio wave. Okay, and the receiver has got circuits in it as well, and you get oscillations in these circuits, and basically that's your signal that you've received. Gamma rays, need to know a little bit more about them. Gamma rays come from nuclei, from the nuclei of atoms. Now, after an atom has decayed, it usually has a bit more energy than it should have. It's not in its ground state, and it wants to get rid of this energy, and it does so by emitting a gamma photon, which is a high frequency photon, a packet of energy. Okay, nuclei that have been left excited after a decay. For example, on this picture, a fission event. Maybe that's a uranium-236 has just exploded, and the nuclei are very excited, and they get rid of energy by giving off gamma photons. Gamma comes from the nuclei of excited atoms. Ultraviolet. Now, ultraviolet, X-rays and gamma are dangerous because they are ionizing, and I've talked quite a bit about this in my radiation videos, in the hazards of radiation, and I've talked about sieverts and millisieverts and doses and risk. It mentions it again in this part of the specification. So basically, ionizing radiation, it can damage body tissue, it just kills cells, it can cause mutations, and it can cause cancer. Cancer is when your body cells just multiply and multiply. And the higher the dose, the greater the risk. Yeah, the higher the dose, the greater the risk. Just an interesting thing about mutations. What's a mutation? Well, if the chromosomes of a gamete, for example, a sperm cell, are altered, then if that actually fertilizes an egg and the fetus starts to grow, then something strange, something different is going to happen. Now, most mutations will fail. They won't be born. The egg won't be fertilized. It won't divide. But every now and then, mutations are born, and it's actually an important part of evolution. You know, if the change that it produces increases the chance of that individual reproducing, then it could pass that on to its offspring. This isn't a biology lesson anyway. Interesting though. Ultraviolet, now unlike visible light, can penetrate deep into the skin, and it can do lots of damage, okay, to the inner layers of the skin. And this can cause premature aging, and it can also cause skin cancer. Again, it depends on the dose, the amount of exposure. And this is interesting, but you don't need to know. These kiddies here have got dark skin, and that protects them from ultraviolet. Because the dark skin actually absorbs the ultraviolet, and that stops the ultraviolet penetrating deep into the skin.